Good afternoon, everyone. Welcome to our Wet Season Outlook webinar for the November 2019 to April 2020 wet season period. Today we'll be discussing the monsoon onset, the tropical cyclone outlook, and tropical rainfall climate drivers. A big welcome to our first-time webinar attendees and welcome back to our regular attendees. We appreciate your ongoing support. My name is Claire and I'll be your moderator today. I'm joined by Angela, who will be producing today's webinar. Hi, Ange.
Hello, Claire.
Together we will help make the webinar as interactive as possible. Before we start, may I ask for your attention as we cover off some housekeeping items. Our broadcast today will run for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen. More importantly, please note the chat box where you can send through any questions or feedback for the presenters. Please use the chat box, not the Q&A box, to send your questions to us during the session, and we will answer as many as possible during the allotted breaks. If you'd like to test out the chat box now, feel free to tell us your name and where you're dialing in from. In response to feedback received from previous webinars, here is some information on how to participate in our polls. When a poll is in motion, attendees will see a set of questions to the right on their webinar screen. Please select your answer choice followed by the submit button below them. I will also take this moment to thank everyone who sent us in questions during your registration. We have developed the content of this session in accordance with the common themes of those questions, so thank you for helping us. And thanks to Brett from Queensland who's using the chat beautifully. So finally, I am delighted to introduce our expert presenters who will lead our discussion today. Please join me in welcoming Jonathan Pollock and Greg Browning.
Good afternoon, Claire.
Hi, John. Hi, Greg. Jonathan joined the Bureau of Meteorology as a weather observer, launching balloons, watching the skies and recording the weather. Later, he moved into Climate Information Services, providing historical context for the current weather and guidance on the months and seasons ahead. Greg has worked at the Bureau as a weather forecaster and more recently as a climatologist. While he has a broad knowledge of meteorology, his specialisation is in tropical weather and climatology, having worked in all three of the Bureau's tropical regions, including 10 years at Darwin. So welcome to Jonathan and Greg. We're looking forward to hearing from you today. Who would like to take us through the content of today's session?
Thanks, Claire. I'll make a start. So here's just a brief rundown of how we'll format the structure of the webinar today. So starting at the beginning, why does Northern Australia have a wet season? We'll have a look at what happened last wet season, obviously particularly important because it was a particularly dry wet season over a lot of Northern Australia. Then zooming into what's happening this wet season in 2019-20, we'll look at the current climate drivers and climate drivers that typically affect the wet season. We'll dig in a bit deeper to, looking at the mechanics of the monsoon and a monsoon trough and when that's likely to arrive this wet season. And then we'll finish off by having a bit more of a detailed look at rainfall and tropical cyclone outlook information for the coming wet season. Okay, so starting at the beginning, what is the wet season? So I thought a good way to broach this subject is talk about the wet season as compared to the dry season. So we've got two pictures here of global wind patterns. On the left-hand side, we're looking at a typical pattern during the dry season, which is the cooler months of the year for Australia. On the right-hand side is the wet season. So what we find across Northern Australia in the dry season is that we're dominated by these dry and relatively cool southeasterly trade winds. So they're winds blowing from the southeast, they pass over the continent and they bring dry conditions to most of Northern Australia. Looking at that left-hand map as well, you can see that those trade winds extend right over Northern Australia and actually into the Northern Hemisphere. And another thing that's in the Northern Hemisphere at that time of the year, which is the dry season, is this feature called the Intertropical Convergence Zone. And that's basically just the focus of where the tropical weather happens. Sometimes of the year it's called the monsoon trough. And what we'll see if we look at the right-hand side diagram is that transitions from the Northern Hemisphere into the Southern Hemisphere in the wet season months. The other thing we can see in the wet season is that those drier southeasterly winds contract further to the south and they actually become weaker over Northern Australia. And this time, instead of winds going from the Southern Hemisphere into the Northern Hemisphere, we have winds travelling from the Northern Hemisphere into the Southern Hemisphere. And that's a key feature of wet season and the monsoon in particular. And we call that cross-equatorial flow.
So wet season in Australia goes from?
So by definition, we say the wet season starts in October and ends in April for Northern Australia.
Thank you.
Okay, so within the wet season, there's two distinct periods. There's one that's often called the build-up and another one that's called the monsoon proper, if you like, or the big wet. So what we see in the early part of the wet season is that it's called the build-up because we're seeing a build-up of humidity and moisture in the atmosphere. And typically it's still mainly a lot of blue sky, very hot, very humid, but not much in the way of widespread rainfall. So looking at that diagram on the left-hand side, a typical scene in the build-up is thunderstorms, generally off in the distance. You're suffering from oppressive heat where you are and the sun's beating down on you and someone else is getting a nice cooling shower. However, if we look at the right-hand side in the monsoon, it's a big change. So the blue skies are properly gone when the monsoon is in its full fury, and we've got thick, moist, grey skies, cloudiness, rainfall, cooling winds, and widespread rainfall, and that's associated with frequent shower and thunderstorm activity that can last for days or weeks at a time, and that's the proper wet. So the typical build-up usually lasts from the start of the wet season, so early October going right through to perhaps middle or late December, and even later depending on what part of the country you're in. And then once we get into around Christmas time in the far north, we start to see episodes of the monsoon, and we'll talk about that in a bit more detail as we move through the presentation. Okay, so just to lay the scene and put some context into what we're likely to talk about this year, we'll just have a quick snapshot now of what the wet season outlook is for the wet season that's already started and lasting through to April. So the take-home points really are that rainfall is likely to be below average till the end of this year. Monsoon onset is likely to be a bit later than usual, likely to see warmer than usual temperatures and below average number of tropical cyclones. So just looking at that in a bit more detail, I've got two maps on the right-hand side there, the rainfall outlooks over the next few months as released by the Bureau. And you can see on the top one, that's a December rainfall outlook. There's a lot of brown, and that's indicating a low chance of average or above rainfall. So right up until the end of this year, we're going to be dominated by a climate driver, which is called the positive Indian Ocean dipole, and Jonathan will talk a bit more about that as we go forward. And that's likely to lead to widespread dry conditions over much of Northern Australia between now and the end of the year. However, what we'll find is that once we head into the new year, that particular climate driver is likely to break down and we'll be heading into more of a neutral state as far as climate drivers go, and then heading more in towards average type rainfall patterns. So that's why there's a lot of white and just lighter coloured shading on that diagram, which is looking at the January to March rainfall outlook.
Greg, Nicole's asked us, has it been late to start this year? So I guess she's talking about the wet season. Yeah, so the wet season is pretty much a technical definition. So that starts each year in Northern Australia on 1st of October. Yeah. Yep. However, the monsoon, which is what we often talk about when the really heavy widespread rains happen, that's yet to happen this year. So that normally happens in about the last week of the year. It hasn't happened yet, as we'll talk about a bit later. It looks like there's a high chance it'll happen later than its average time in this particular wet season. Thank you.
Okay, and on that topic now, why will the monsoon be delayed? And the monsoon and the passage of the monsoon trough is very important as to what the ultimate amount of rainfall over Northern Australia is going to look like. As I said, that's where the really heavy rains happen. So whereas in the early part of the wet season, in that build-up period, we can see isolated and infrequent thunderstorm shower activity, the really widespread heavy rains over far Northern Australia are associated with the monsoon. And as you can see in that diagram, once we get to January, we normally have a monsoon trough lying over Northern Australia, and that's bringing those heavy monsoon rains. Just as a bit of a guide, you can see there's the late monsoon lines a bit further north, and that's pretty much what we're likely to see as we head through the season. Just that trough is still a fair way north of its normal position, and it has to move closer to Australia before we're likely to be impacted by that monsoon. Mainly that's happening because of what happened in the Northern Territory. So again, going back to those early pictures, the monsoon is a global weather system, and so what happens in the Northern Hemisphere can very well impact what happens in the Southern Hemisphere in a few months' time. So we saw a very late withdrawal of the Indian monsoon, and basically that needs to withdraw, and the trough that's laying over India through the middle of the year, through our dry season, needs to then track further south and eventually come into the Southern Hemisphere over Northern Australia ultimately. That's well behind schedule as a result of this positive Indian Ocean dipole climate state that we've been in for the last few months, and hence we're running well behind schedule for the monsoon, and why we're likely to see a delayed monsoon this year.
Quick question from Andrew. He asked, if the monsoon season starts later, will it run later?
Not necessarily, no. So usually it's again the last monsoon activity usually happens during April, and it usually won't happen beyond that. So really it closes down at a pretty regular time as the season starts to change and all those global wind patterns start to revert back to what they were in the dry season. So probably not going to see anything later than a typical sort of monsoon episode. Okay, and with that, I'll hand over to Jonathan, and he'll have a look at a bit of a recap of what happened in last wet season.
Thanks, Greg. Okay, so the map on this slide shows last wet season's rainfall compared to previous wet seasons. So the white shading, that's areas where we had near average wet season rainfall. The blue areas are places that had above average wet season rainfall, and the red areas are places where it was below average or drier than usual last wet season. Now you'll notice that for a lot of tropical Queensland, they reported between average to above average rainfall, but for most of the Northern Territory and Northern WA, rainfall was generally below average or very much below average. I'll draw your attention to the rainfall around Darwin. That's the little green circle at the top of the map, and you'll notice that it was generally very much below average last wet season. And we'll compare that to the little circle on the coast of Queensland around Proserpine, where you can see the blue shading means that the wet season rainfall was above average. Now, last wet season's rainfall total doesn't tell us what to expect for this year, but it helps to explain some of the impacts that we've seen in the environment since then. So now on this slide, the top half is some storage information for the water levels around Darwin. And on the bottom half, there's information for water levels around Proserpine. And what you can see in the top right is a time series chart of the water levels around Darwin, and there's a sawtooth pattern. You'll notice at the start of every year, there's this big uptick where all that rainfall gets transformed into inflow, into storage, and then then the volume peaks, and then throughout the year, it starts to decline as we tap into that reservoir. If you look at the latest year, you'll see that there wasn't much of a refill in 2019. So you remember on that last slide, we saw there's below average rainfall around Darwin last year. And one of the impacts of that was that we didn't get the same amount of refill that we normally would in storage. And so you can see that compared to this time last year, storage levels around Darwin have dropped by about 22%. And we can contrast that with Proserpine. So that was the region in Queensland that had above average rainfall. And you'll see that in their time series chart, in the bottom right-hand side, that there is quite a large uptick at the beginning of the year, corresponding to the inflow from that above average rainfall.
So, Jonathan, does last year's wet season tell us about this year's wet season?
No, it doesn't tell us how this wet season is going to be, whether or not we'll have a sort of above or below average rainfall, but it helps explain some of the impacts that we see sort of on the ground throughout the year.
And it shows some places are starting off a bit drier than they would otherwise imagine, yeah?
That's right. In terms of storage, there's some places that are starting off lower than they were at this time last year.
Thank you.
Okay, thanks, Jonathan. I'll have a bit of a look at more average trends of rainfall or average amounts of rainfall during the Northern Australian wet season, and also look at some recent rainfall trends which some people might find quite interesting as well. So on this slide we have two images. On the left-hand side we've got a map of Australia, and it's showing rainfall that happens in an average wet season, so from October to April, based on data that's been collected over a number of years. And I guess a few things are quite apparent is that there's a large variation. So if we look at some of the southern parts of the region, say around Alice Springs in Northern Territory, Longreach in Queensland, Newman in Western Australia, rainfall is typically only 200 to 300 millimetres for the wet season. As we go further north, areas that are more affected by the monsoon throughout the wet season, we can see there's large areas of far northern Australia that are in excess of 1,000 millimetres per wet season. And just to pull some numbers out of the hat, Darwin's close to about 1,700 millimetres and Cairns is close to about 1,800 millimetres in a typical wet season. So first of all, there's variation going north to south. The other thing that we see with those colours in the south, particularly over the Northern Territory and Western Australia, it gives us a bit of an idea of the extent of the influence of the wet season and monsoons as well. So the monsoon can actually influence parts as far south as Alice Springs and along that sort of latitudinal line throughout a wet season. It spends more time over those parts in the north, so that's why they get more rain, but occasionally it can drift down to those areas that are relatively far south in Northern Australia. On the right-hand side, we've just got a breakdown of average rainfall per month during the wet season, and I guess a couple of things that are quite apparent is that at sort of each end of the wet season, the start and the end, rainfall is much lower than what it is in the heart of the wet season. So the really heavy times are January and February, and the bulk of the rain basically happens in the December to March period.
But as you say, the big spike's January, February.
That's right. So January and February are by far the heaviest rainfall months, and that's when the monsoon trough moves its further south and spends more time over Northern Australia than at other times of the wet season. Okay, looking at this next slide, we've got a couple of graphs here to do with rainfall trends. So on the left-hand side, what we see is rainfall trends over the last 20 years, and it's showing what we have seen over parts of Northern Australia as far as rainfall compared to the long-term average. And the really dark blue is showing that we've seen the highest rainfall during wet season on average, and we've seen an increasing trend for even since about the 1970s, so this goes back about 20 years, but basically there's been a trend for increasing rainfall over most of Northern Australia for the last 40 or so years. One thing which this map doesn't show is that most of that rainfall is happening in those really high rainfall months, so in the January, February, March period. So what we're seeing is that the wet season is pretty much getting compressed in a sense. So we're seeing the heaviest rainfall pretty much compressed into those 3 months of the wet season, and generally it's composed of particularly heavy rainfall events, and that's something we're seeing more of over a lot of Australia. The proportion of rainfall that comes from really extreme rainfall events has been increasing in recent years. And these increases over Northern Australia in particular seem to be mainly driven by the increase in sea surface temperatures. So that's shown on the map on the right-hand side. So those deeper shades of red are just showing a significant increase in surface temperatures. And if you can think back to those wind patterns we were looked at earlier, the monsoonal winds are associated with northwesterly winds which come from right across the other side of the equator, move over northern Australia and pick up that moisture, and there's more moisture available with those higher sea surface temperatures, and ultimately drops that over northern Australia in the form of rain.
Great, thank you, Greg. Back to Ange over here, getting a bit of audience participation. We're about to launch a poll and we're keen to hear from our audience on the question of when does Darwin get most of its wet season rainfall? So the answer choices there, A, October to December, B, January to March, C, February to April, or D, 2 big downbursts. And so while we leave that open for a moment for everyone to get their answers into us, Claire, I believe that we've received some messages from our audience.
We're getting heaps of questions, which is great. We're getting a few cyclone questions, and I know you'll be talking about that later in the presentation. Although someone asked if the monsoon and the cyclones are related.
Yes, they are indeed. So, yes, very good question. So typically, cyclones form actually along the monsoon trough, and we'll talk a little bit more about what the actual monsoon trough is. But yes, at times when the monsoon is at its most active and we do see this monsoon trough over water, that's when we're likely to see tropical cyclone activity. So yes, there is quite a strong relationship between monsoons and tropical cyclones.
Thank you. Somebody asked about, it was Nicole who was asking about where can we find the water storage graphs? I think that was on your slide, Jonathan.
Yeah, that's right. All those water storage charts are available from the Bureau's website. We have a water information portal that has all that storage information, and plenty of other water information too about.
Search on water storage, it should tell you, yeah?
Yeah, we've also got stream flow and soil moisture and lots of other water information there too.
Thank you. Ron asked, showing trends of water recharge, do you also see weather instability growing on top of decline? And Ron's coming in from Indonesia today. Tricky question. Any ideas? Tricky? Oh, you stumped him, Ron.
Yeah. So it's interesting. I don't know too much about Indonesia, but just talking about Northern Australia. So as we said, there's been this trend for increasing rainfall during those wet months, so basically January through to March. What we are seeing is a little bit more variability outside of those months. So within those early and the late wet season months, we're seeing a bit more variability there. So we're seeing these heavy rainfall events. And one thing which we've started to see, and might be more of an issue heading into the future, is that when we get a higher proportion of our rainfall with these very heavy rainfall events, often we see increased runoff basically into the environment, and not so much gets trapped and goes into the inflow and dam regions as well. So potentially that could be an issue for recharges of water systems in the future if that trend becomes stronger over time.
Thank you. And the rainfall trend map that you showed us shows the wet season getting wetter in essence, although that didn't happen everywhere last season.
That's right. So this is based on average years over 20 years. So we have actually seen a couple of dryish years just lately, but we've seen some very heavy rainfall wet seasons as well over the last 20 years, and seen the highest on record back in about 2010, where we saw nearly 3 metres at Darwin, for instance, and there's been some very heavy years. There still have been the lighter ones, but as we look at the bigger picture and the longer averages, we're seeing an increasing amount of rainfall in those regions affected by the monsoon and the wet season.
Is that extra cyclones, or is it?
No, it really hasn't had anything to do with cyclones, because we'll talk about it a bit later. We've actually seen a decline in cyclone numbers. So again, it has to do mainly with those warmer sea surface temperatures around Northern Australia, and that's basically the source of the rainfall. So those monsoon winds pick up all that extra moisture in the air and basically dump it on the continent as rain. So that looks to be the main explanation at this stage for the increasing rain.
When we get it, we get a supercharged monsoon.
Yes, it has been that way. So yeah, we've seen those, especially during those January, February, March period, seen a lot more rain than what we have earlier in the century.
Thank you. We've got more than 250 participants online, and I think most people have had a go at voting now. So we'll close off our poll and just have a quick look at the results.
Absolutely. Thank you to those of you who got involved in our poll and submitted your answers. For those of you who didn't, just a refresher in case you're not sure how to participate, the question with the answer choices should pop up to the right of your screen as an attendee. And just remember to click submit once you've selected your answer choice. So with that, I will let you all know, or let our presenters know, you'll be very happy to know that the majority of our listeners did select option B, which I believe is the correct answer. So that's fantastic. What does that say about our listeners?
Yeah, you're right, Ange. We've got a very clever bunch listening, but I always knew they would be a clever bunch. But yes, they're spot on. January to March, that's when we get most of the rainfall. Excellent work.
Perfect. All right.
Please go on, Greg. Thank you.
Okay, we'll move on to Jonathan now, and he'll talk a little bit about climate drivers.
Cheers, Greg. So on this map, you can see the major climate drivers that affect Australia. And today we're going to focus on the ones that influence the wet season. So that's the Madden-Julian Oscillation, the monsoon trough, and the Indian Ocean Dipole. Now we'll start off with the Indian Ocean Dipole. What is a positive Indian Ocean Dipole? Well, there's a diagram on this slide which shows you that when we have a positive Indian Ocean Dipole, we have a pattern in sea surface temperatures where we have warmer than usual waters off the Horn of Africa, and we have cooler than normal waters around Indonesia or sort of off northwestern Australia. And these are sort of sustained changes. These are changes that we see happening over months or several months. And that influences or has an impact on the atmosphere above the oceans. And what it does is it draws the focus of cloudiness and rainfall across to that warmer water, over closer to Africa, and away from Indonesia, away from Australia. And what it can mean for large parts of the country, not just the tropics, it can mean below average rainfall. And often, for southern parts of the country, that's during our winter and spring months. But you're going to find out that it also has an effect on the wet season too. Now, the current strong Indian Ocean Dipole is sort of comparable to other strong events we've had back in 97, 94 and 61. And now normally an Indian Ocean Dipole breaks down at the end of spring when the monsoon trough comes into the southern hemisphere. But this event is so strong that it's likely to take a bit longer than usual to decay.
And just real quick, somebody's asked, where is El Nino and La Nina? Why are we talking about positive IOD?
Well, currently out in the Pacific, El Nino, La Nina or ENSO is neutral, so they're not having a strong push on our climate patterns either way. But now, the reason why the IOD is important in a chat about the wet season is because in the past, what the Indian Ocean Dipole has been up to has affected when the monsoon sort of has arrived over the tropics. Now, on this diagram in front of you, each column represents a date that the monsoon began in Darwin. And then we've ranked all those dates from earliest. So on the left-hand side, you can see to the end of November, up to the latest. And that's on the right-hand side, you can see that's late January. Now, the horizontal black line in the middle, that's the average onset date. And you can see that's late December. Now, we've colour-coded each of the bars depending on what ENSO and the Indian Ocean Dipole were doing at the time. The ones that were positive IOD, that's the yellow shading, and they also have the arrows pointing down to them above the bars. And what you can see is that typically, in a positive Indian Ocean Dipole event, the monsoon onset date happens later than the average. So it normally happens after the end of December.
So those three yellow bars above the line.
That's right.
It came late.
There's three yellow.
Late December.
There's three yellow bars above the average date, sort of on the right-hand side of that chart. But you'll notice there's still one yellow bar right on the left-hand side of the chart too. There's a positive Indian Ocean dipole year that had a fairly early onset date for the monsoon, but generally it happens later than usual. Now, so a positive Indian Ocean dipole often means a later start to the monsoon, but it doesn't have a big impact on the back end of the monsoon or what happens in the new year. Now, these maps are composites of the average rainfall you get at the beginning of the wet season and the second half of the wet season during a positive Indian Ocean dipole year. So the blue and green shading are areas of above average rainfall, and the yellow and red shading are areas of below average rainfall. So on the left-hand map, you can see that rainfall from October to December, or the first part of the wet season, during a positive IOD, is typically below average for parts of Queensland and the top end as well. But you see on the right-hand map, a lot of the tropics have that neutral shading or near average rainfall, and what that's telling us is that in past positive Indian Ocean dipole events, there hasn't been a big impact on wet season rainfall into the new year.
Okay, thanks, Jonathan. I'll go into a bit more about the details of the monsoon trough, monsoon variability, and also talk a little bit about the Madden-Julian oscillation, which is also a very important climate factor during the wet season. Okay, so we've been introduced to the monsoon trough by Jonathan, who showed us one of the features of wet season for Northern Australia. And you can see we've got two maps here, and they basically show two different phases of the monsoon. So they're idealised versions of the monsoon, but typically when the monsoon is active, we see this monsoon trough lie over Northern Australia. And you can see to its north of those northwesterly winds that are laden with moisture. They've got the strong gusty winds and showers associated with it, and that's where we get the really heavy rainfall. However, it's certainly not as clear-cut as that in a couple of ways. So first of all, we usually don't see a monsoon trough that just extends unbroken that length of distance. Sometimes it will be affecting Eastern Australia and not affecting Western Australia. Sometimes it will be affecting West Coast and the East Coast, and the Northern Territory will miss out, and it does all sorts of different things. Last year was a classic example where we had a monsoon trough very active over Queensland, caused major flooding there, but there was really nothing resembling a monsoon trough at all over the Northern Territory and Western Australia for large periods of time during the monsoon. But if we stick with this idealised picture, on the left-hand side we're talking about an active monsoon, so this is when we're seeing those wet northwesterly winds and the really heavy rains. But after a while, the monsoon trough drifts away from Northern Australia, and you can see on the right-hand map there, the monsoon trough has moved north of the mainland, and at that stage, we're basically back into those drier easterly winds. So it doesn't slip right back into a dry season pattern because there's still so much humidity and heat in the atmosphere that we go back to like a build-up sort of pattern where there's just isolated showers and thunderstorms. So that's a pattern that we see during the monsoon season. So once we get that first monsoon activity happening, that's called the monsoon onset. And as we said, that typically happens around the last week of the year in Darwin. We see 2 or 3 bursts of activity where that monsoon trough lies over Northern Australia during the season, and then in between times, for a couple of weeks at a time, that monsoon trough might drift further north and we go back into sort of a lower rainfall period.
What are you looking for when you're looking for a burst?
Yeah, so we can actually see, as you can see by those L's there, it's looking for a big area of low pressure. So we see low pressure troughs. And this goes back to the earlier question we had about tropical cyclones. So those lows can often form in the monsoon trough. and if they lie over water for long enough, they can develop into tropical cyclones. So we're looking for these areas of low pressure, and they become the focus for weather, and that basically just builds up on itself, and we get more and more rainfall. We get low pressure systems develop, and they draw in those winds from across the equator, and the really heavy rainfall associated with that. Okay, so imagine Julian oscillation we can think of as a pulse of weather, and it has a very strong influence on the timing of those active and inactive periods of the monsoon, as well as it's instrumental sometimes in the formation of tropical cyclones. So the Madden-Julian oscillation, again, is a climate driver. It's not as broad scale or long lasting as something as like the El Nino or a positive Indian Ocean dipole. What we see is this pulse of weather associated with the Madden-Julian oscillation, or MJO, travels around the globe in a period of about 30 to 60 days, and depending on where it is, it will either lead to periods of enhanced or reduced rainfall. So you can see those diagrams where we've got the pulse of weather in 3 different locations. When it's over the Indian Ocean, we're likely to see reduced rainfall over Northern Australia. As it moves into our neck of the woods, so over Indonesia, Papua New Guinea and sort of areas like that, we see some increased rainfall. That's often the time of the year that we might see an active burst of the monsoon, higher risk of tropical cyclone development in the Australian region. And then as that MJO moves further east into the Pacific Ocean, we go back into the period of reduced rainfall. So yeah, the Madden-Julian oscillation is very important during the wet season, and it gives us a really good guidance on when we're likely to see above or below average rainfall. And it's quite forecastable for out to about 2 weeks. So it's a really good guidance in the tropics, where we don't often get some of the things like cold fronts and other features you see in the mid-latitudes. And it's something that can really give us a good idea on when the weather is likely to change over Northern Australia.
Thank you. Angela, you've got another poll. We've got a heap of questions too.
Absolutely. So thank you to everyone who sent in questions. I did pop a note in the chat to those of you who saw it that there is a very large audience with us today. And so if we don't get to your question, we have popped an email address in there where you can contact us after the webinar. So please do so. So we've launched our poll. The question that we'd like to know your answer to is, when does monsoon usually start in Darwin? Answer choices there are A, 26th of November, B, 26th of December, C, 15th of January, or D, 1st of February. Now, once again, if anyone is unfamiliar with how to use the poll system, there should be some questions to the right of your screen, and once you've selected your answer choice, please don't forget to click the submit button. That would be fantastic. So Claire, over to you for some questions.
Thank you. We've got a heap of questions, haven't we, Ange? We had a great one from Jude. Jude asked, how often is the onset of the first monsoon associated with the MJO?
Good question. Probably more than half of the time, the MJO is a prime factor. So usually we need to wait until late December, early January for the atmosphere to be primed properly. Then it's like it's getting a bit of a kickstart from the MJO. So that extra active pulse of weather that moves into our region, that can be the sort of thing that can just really just get everything focused, and we start to see the monsoon trough develop and become quite strong. So MJO is associated with a lot of monsoon onsets.
That's a yes.
I'd say yes. Yep. I don't know the numbers off the top of my head, but I would say yes, certainly more than half.
That's good. So keep looking for that MJO. Anthony asked, did the monsoon trough cause the flooding in Townsville this year? Do you know the answer to that?
Yes, it did. Yes. So we had a monsoon trough basically just sitting on the coast around Townsville for a while there, and just didn't move at all, and so we had very heavy rainfall. Yeah, that's right. So it really, and it's a typical sort of thing. So it's either usually those tropical lows or cyclones, or something like the monsoon trough will just sit in one location and just dumps heaps of rain, and then that monsoon trough also extended into central Queensland, and we saw major flooding happening in that part of the world as well, yeah.
Thank you. Justin asked, is tropical cyclone severity proportional to monsoon intensity if the tropical cyclone forms from the same system? We've got some good weather watchers in this webinar, haven't we?
Yeah. I'll have a stab at that. The monsoon pretty much is a strong determinant on whether you're likely to see a tropical cyclone form. However, it's got much more to do with the small-scale environment once the actual lows start to develop. So you really need things like the right winds, the right moisture profile around that cyclone, and they pretty much determine on how quickly and how strong the cyclone will develop. So it really is not so much of an influence on those broad-scale factors like the whole monsoon. It's more to do with small-scale features at that stage.
Thank you. Andrew says, I see the sea surface temperature off the coast of New South Wales very warm, but not a lot of rain in that part of the country. I guess just because it's warm doesn't mean it's going to rain. Is it
well, that's right.
It's a bit more complicated than that.
On the wind flow as well, and sort of what's driving that above average rainfall in the wet season is the wind flowing across those warmer waters to the north of us.
Thank you. Christina asked, how is the wet season going to impact Western Australia this year, especially the Pilbara region?
Yeah, well, pretty similar to what it's likely to impact the rest of Northern Australia, I would say. So again, we're likely to see relatively dry conditions, although Western Australia isn't typically influenced by the positive Indian Ocean dipole as much as other parts. So really it's going to depend on just how good the monsoon is, and places like the Pilbara are really notoriously variable because they're sort of on the edge of the influence of the monsoon a lot of years. So often it takes a tropical cyclone or a tropical low that stays over land for a while to deliver a lot of rainfall for those events. So that's well beyond our forecasting ability to say how many or where they may form. But I guess one thing that we're trying to stress through this outlook is that while the rainfall is likely to be below average till the end of the year, once we get into the new year and there's nothing like an El Nino or any other climate drivers likely to produce below average rainfall, we're going to head back into more of an average type season. So yeah, it's just a 50-50 chance really of whether we're going to see above or below average rainfall over any particular location in Northern Australia.
Thank you. What were our poll results, Ange?
Well, I'm glad you asked, Claire. Thank you very much for doing so. Our most popular answer choice, unsurprisingly, I guess, is answer choice B. So 26th of December, and how did that fare?
Again, as we said the first time, there's a pretty bunch of clever cookies out there, so yeah, you're spot on. So that's the typical time. That last week of December is usually when we see the onset of the monsoon at Darwin. So yeah, well done everyone out there.
Fantastic. All right. Moving on with the presentation.
Cool. Thank you very much, Ange. I'll just finish off with one slide to bring together a typical wet season, if you like. So what we've got is a bit of a graph showing a passage of the wet season starting in October down the left, bottom left, and moving right through to April. So in summary, we basically see we're looking at a transition or a build-up period in the early part of the wet season, October and November, and then into December. And then it's not until the atmosphere is properly primed and we get a monsoon trough develop in the southern hemisphere that we're likely to see the onset of the monsoon. And as we've just talked about, it's typically in late December. And then we have those phases of the monsoon. It sometimes is active, sometimes is inactive, and then you'll have 2 or 3 of those bursts of activity and inactivity during the season. And then it just peters out into April, and we start looking towards the dry season from then.
Thanks, Greg. Now we'll have a chat about the official outlook for summer and the beginning of the wet season. So there's 3 maps, and each of them is a rainfall outlook. The one on the bottom, or the one on the left-hand side is for summer, December through to February. The one in the middle is just for the 1 month of December, and the one on the right is for January. And you can see that for summer, it looks as though there's a lower chances of above average rainfall for much of Queensland and parts of the NT. However, other areas, there's no strong push towards sort of a wetter or drier than usual 3 months. And across northern WA, there's even an indication that there's an increased chance of above average rainfall for December through to February. But if we break that summer down into its individual months, you can see there's an interesting story. So for December, that's the middle map, you'll notice that a lot of Australia is forecast to be drier than usual, and especially so over northern Queensland and eastern parts of the top end. And now this has to do with what we were talking about before, with the Indian Ocean dipole, the positive Indian Ocean dipole, influencing drier rainfall patterns at the beginning of the wet season. Because you can see there's a big difference between the outlook for December and the outlook for January. That's the map on the right-hand side, where now most of the country, including the tropics, has no strong push towards above or below average rainfall. So what we're seeing there is the Indian Ocean dipole influence backing off at the end of the year, and so no strong push towards wet or dry from the beginning of next year. Oh, and I've got to mention, we update the outlooks map. We update the outlook maps now. The weekly and fortnightly maps get updated twice a week on Mondays and Thursdays, and the monthly and seasonal maps get updated every Thursday. So there'll be some new maps out at the end of the webinar. You should check them out. But overall, the rainfall pattern is not likely to change a lot. Now, we don't just have maps of chance of above or below average. We also have maps that people can tailor to their own decisions. So here's a screenshot from our website. And under the rainfall section, rather than chance of above median, you can select from our chance of at least product, and you can set a custom threshold in there. And you can base that around your particular decision making. So as an example, I've selected 400 millimetres there, and it's showing you what the chance of getting at least 400 millimetres is for December through to February. And as Greg showed in his average rainfall map before, northern parts of the country have normally receive a lot of rainfall at that time of year. So those places have very high chance, greater than 90% chance of getting their 400 mils, and that those odds gradually reduce the further south you go.
Thanks, Jonathan. And we'll just wrap up this outlook by looking at some tropical cyclone information. So we've got a few images here. The top left-hand one is just showing where tropical cyclones typically influence Australia and the time of year. So tropical cyclone season is current now, starts in November, runs through till April. And we look at the right-hand map with all the squiggly lines. They're basically historical cyclone tracks over northern Australia. So you can see pretty much any part of northern Australia can be influenced by tropical cyclones and has been at some stage in its past. The map below is showing the frequency of cyclone numbers per season, and you can see there's a fair bit of variation from as low as 3 cyclones in 2015, which is associated with a strong El Nino year, right through to some years in the early 1970s where we saw up to 19. And you can see the 3 different colours on that graph. So whereas we've been talking a lot about the positive Indian Ocean dipole, when it comes to cyclone numbers, we look at the El Nino numbers, and generally El Nino is associated with low tropical cyclone numbers, and the opposite phase, the La Nina, is associated with above average tropical cyclone numbers. Won't spend too much time on that, but I guess the salient points are that we've seen at least one tropical cyclone has crossed the Australia coast every year, even when we've only had 3 tropical cyclones form across northern Australia in any year. And it's also not just the tropical cyclones that are the real problem. So tropical cyclones can come in many forms, and when they move over land, they can become big flooding depressions or tropical lows. And even a low that hasn't developed tropical cyclone strength can cause a lot of rainfall. So whether it's a tropical low or a tropical cyclone, both have the potential to generate a lot of hazards.
Greg Kai says your map needs a haircut, but I think actually that's the spaghetti diagram that just shows the range of paths for cyclones. Matt asks, you can see a downward trend in cyclones since 1970.
Yeah, it's quite interesting actually. There has been quite a pronounced downward trend in numbers, and this has happened over many parts of the globe as well. So we have seen decreasing numbers. At the same time, we've seen more of the stronger cyclones as well. So the Category 4 and Category 5, we're talking about Australian cyclones. So yeah, there has been a trend, and that trend is forecast to continue into the future.
And how does this year's trend look?
So, well, I'm glad you asked. We're about to get right onto that. So, the tropical cyclone outlook for 2019-20, and again, it's influenced a fair bit by this positive Indian Ocean dipole in as much as it's likely to see delays at the start of the monsoon. And we've talked about the relationship between the monsoon and tropical cyclone. So those numbers you can see with the percentage numbers, they all have to do with the chance of seeing more than usual tropical cyclones in particular regions. So the take-home one down the bottom are Australia overall. So in a normal year, we see about 11 tropical cyclones these days. We only have a 35% chance of seeing that number. So more likely than not, we're going to see less than 11 tropical cyclones. Again, as I said, our forecasting is not good enough to say where they will form, when they will form, or how strong they will be. So, yeah, it only takes one cyclone to really mess your neck of the woods up. So it really doesn't really matter whether it's 1 or 11. We always say just be ready for the worst case scenario and keep an eye out for any of tropical cyclone advices issued by the Bureau if there is something brewing anywhere near your part of the world.
Thanks, Greg. This is our last question session, so if you've got any burning questions, send them in now. Graham asked, any theories around the wet season conditions occurring in the western half of Australia? They're good questions today, aren't they?
They are, and it's interesting, you looked at that map that the strongest trend was over in Western Australia, and the strongest trend in the sea surface temperatures as well was over that part of the world. So it wasn't as strong over in Eastern Australia, and hence we haven't seen quite as strong an increase in rainfall for the wet season there. So I'd say again it's quite a strong relationship to those increasing sea surface temperatures.
Thank you. Simon's very learned. He's asking us, to what extent is the southern stratospheric warming influencing the current and predicted wet season patterns?
That's a very good question. The southern stratospheric warming really doesn't have that much of an impact on the monsoon, and it's likely to be pretty much all done and dusted even before the positive Indian Ocean dipole collapses. So at that stage, we're likely to head into a neutral climate state. However, I guess what's topical at the moment is that seems to have a strong impact on the really hot weather we're seeing over parts of Eastern Australia, New South Wales and Queensland, and you know, is probably influencing a lot of the adverse fire weather we've seen in those parts of the world.
Thank you. There's a few people commenting on less cyclones and more intense in the 70s, so it's definitely a defined pattern, isn't it? Would you like to go on with our summary?
Thank you, Claire. So yeah, just a quick wrap up of what we've talked about today, and we'll give you some links as to where you can find out more information. But we've talked about why we do have a wet season, how it differs from the dry season, how the monsoon is associated with those warm, humid winds that come from the northwest and across from the northern hemisphere. Talked about monsoon and their phases. So it starts with the onset, which we officially define as happening at Darwin each year, and it happens around Christmas time. Monsoons can be of both the active and the inactive variety, and the active is when we see a lot of rainfall. At this stage of the year, we're heavily influenced by a climate driver called the positive Indian Ocean dipole, and that looks to be disrupting tropical rainfall patterns and is likely to lead to a delayed onset of the monsoon for this current wet season. Had a quick look at the Madden-Julian Oscillation. That's the main shorter-term climate driver of tropical weather, in particular its influence on monsoons and tropical cyclones. And we've had a quick look at rainfall in 2019-20, and in particular, it looks to be a tale of two halves, so dry up until the end of 2019 and looking like near average thereafter. And tropical cyclones as well, off to a slow start for the season, and ultimately greater than 50% chance of seeing less than our average number of cyclones in this season.
And in short, monsoons running like possibly 2 to 4 weeks?
Yeah, that's interesting. It is well behind schedule. It's very hard to say, but yeah, if I was a betting person and looking at some historical precedents we've had, I would think, yeah, between 2 to 4 weeks late. So it's more likely to be sort of second or third week of January than, you know, the last week of December, which it is on a normal year.
Or on the build-up is lasting a bit longer.
Unfortunately for the people up there.
Okay, and if people want more information, and particularly to track the MJO.
Yep, so we've got a whole bunch of information here. So some of it's more general, a lot of the stuff that Jonathan talked to regarding the rainfall outlooks, but there's a fair bit of tropical cyclone information. That second one there to do with the tropical climate note, that's a product that's released on a weekly basis. If you are interested and need to make decisions based on tropical weather, that's always a good one to keep an eye on. Matt and Julian oscillation, a whole lot more information there as well, and a whole bunch of information there. So yeah, feel free to have a dig around. There's a lot of good stuff there. But yeah, there's some good places to start if you're interested in anything at all to do with the wet season.
Awesome, thanks Greg. So our next BOM webinar will be on the 5th of December, and will provide listeners with the summer 2019 to 2020 climate and water update. The registration link can be accessed now via the chat, and there's also a link on the screen. So that brings us to the end of our webinar today. Any questions that we didn't get to, please email helpdesk.climate@bom.gov.au. And a very big thank you to Jonathan and Greg for your time in developing the content and sharing your knowledge with us.
Thank you.
Our pleasure.
Thank you. To our audience, thank you for tuning in and joining us today. We hope you enjoyed the session, and we do hope you'll join us next time. If you would like to continue the conversation, please use the hashtag BOMWebinars in your LinkedIn post. And as mentioned earlier, the session has been recorded, and we will have the video ready for your on-demand viewing pleasure in the next day or two. Finally, but most importantly, we want your feedback. It is our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experiences with us. Once we close the webinar, a short survey will pop up on your screen, and we'd be very grateful if you could complete that anonymously for us. I just have a quick question. There was someone who was asking us about the photograph, and you were exactly right in asking it is Yorkeys Knob in Cairns. So well chosen, well picked. So thanks everybody. Once again, thanks for your time. We look forward to seeing you again in future webinars, and goodbye.